Hello there. Welcome back. This is Vasudev, product planner for power solutions in the Tektronix Oscilloscope product line. Today we are going to briefly discuss about the new capabilities we have added to the automated power measurements, the two-port impedance measurement capability using the oscilloscope. Customers need to perform their power distribution network impedance to ensure that the designs are optimally designed as per the requirement. Traditionally, customers have been using a standalone impedance analyzer or a vector network analyzer, but the power design teams need to perform these measurements very close to the DC, which can be very easily achieved using an oscilloscope-based measurement of two-port impedance. We leverage our MSO 5 or 6 series with built-in AFG, or one can also use an external AFG 31000 series. You need to have the appropriate probes. In this case, we have used a TPR power rail probe, or one can also use the direct SMA with DC blocks. We need the commercially available isolation and injection transformers. And here what you see is a brief video of the setup of what we are using for our two-port impedance network capability. We use the Picotest transformers here, and we have for this particular demo used a TPR 4000, the Tektronix power rail probe, which goes up to 4 gigahertz. Probes are connected to the AFG stimulus and the reflected signal, and we'll see that we now take advantage of the built-in AFG of the MSO 5 and 6 series. You need a 50 ohm power divider to ensure that the signals are split between the reference channel, that is channel 1, and the second output goes to the DUT. 50 ohm matching is very important for impedance measurement. Your entire setup should be 50 ohm match. So use the good quality 50 ohm matched SMA cables. The software now gives the ability to select the frequency response analysis impedance measurement capability, which allows users to configure the requirement as to where the AFG signal is fed as a reference, the channel 2, which is a reflection from, and you can also now select an external AFG 31000 series. For the demo purpose, we have used an internal AFG capability. You can set your start frequency, say 10 kilohertz. You can set your amplitude, either constant amplitude or also have profile. Here we have selected 1 volt, and once we set power preset, the software automatically has invoked the AFG option, and now the software starts sweeping from start to stop frequency. The signal from the AFG output through the power divider, whether passive or active, is fed into channel 1 for reference, and the channel 2 is coming from the reflected signals out of the DUT. The output of the DUT is connected through the J2113 or J2102 Picotest transformers. As you see, the software calculates the impedance. Now the oscilloscope has become an impedance analyzer with x-axis as frequency and the y-axis as impedance. You can also invoke the table, results table, and capture all these details into a HTML or PDF format. So with this capability, Tektronix has now ensured that the general purpose oscilloscope is converted into a powerhouse, so to say, with the ability not only perform the automated power measurements but also the two-port impedance measurement. What you need is option AFG for the 5 and 6 series, or you can use an external AFG. In summary, a one-box solution making the general purpose Tektronix MSO 5 and 6 series oscilloscope into a powerhouse for power related measurements. You can also find out more details from Tech's website or contact me, Vasudev or Gajendra Patro. Thank you very much.